Problem 1a is asking us to graph the rational function that has the given properties and write a potential equation for it. It says I have a hole at x equals 5. I'll put that hole into the graph once I have it. I'm going to put that into my equation right now so I don't forget about it. I have vertical asymptote to x equals 3. That means I have x minus 3 in my equation. Another vertical asymptote at x equals negative 2. That's an x plus 2 in my equation. I have an x-intercept at 1 and an x-intercept at negative 4. That's going to be an x minus 1 and an x plus 4 in my equation. And a horizontal asymptote of negative 3/2. And I can just put negative 3/2 in front of my equation. Now I just have to graph the behaviors of the equation. Because it's odd and negative, I know that the ends are going to look something like this. And then I can plug in some values to figure out what's going to happen in my middle section. I already know that I have this x-intercept at 1, so maybe I just plug in negative 1 and see what happens. So when I plug in negative 1, I get negative 3 over 2. That stays the same. Negative 1 minus 5 is negative 6. Negative 1 minus 1 is negative 2. Negative 1 plus 4 is positive 3. Negative 1 minus 5 is a negative 6, and that cancels out. Negative 1 minus 3 is negative 4, and negative 1 plus 2 is 1. That gives me negative 3 times negative 2 is positive 6 times 3 is 18. 2 times negative 4 is negative 8 times 1 is negative 8. That's going to give me about negative 2 1/4. Well, knowing these 2 points, I can say that my graph is going to look like that. The only other thing that we need to do to our graph is that we need to make sure we include the hole at x equals 5 so that we can attend to precision.